Module 8, again, Module 8 may go a lot faster than what's slated, 30 minutes it's allowed, but what you'll see is that we just got through talking about chemical contaminants, and it's essentially the same information that was in that particular module with the chemical contaminants. So hopefully you'll be able to define radionuclides and talk about that rule. We'll give you the overview, the health effects, and right now you probably can tell me all the health effects. Anyone remembers the health effects?
Glow in the dark.
I don't believe glowing in the dark was one that we mentioned.
Increased cancer, kidney disease.
Very good, very good. Very good, you were listening. Super. Now it won't work, okay. Again, we've established in the previous module that a lot of your radioactive material is naturally occurring. That's how it gets into our water system. It's not from people illegally dumping or companies not doing it right years past. But again, what type of rock formation do we have? So it's deposited in surface water, also from the air, mentioned that, enters the groundwater through erosion, seepage, or human activities such as mining, farming, stormwater, industrial activities, and it dissolves from underground mineral deposit as the water flows over it, picking up those impurities.
But now, but we don't use the 3 Mile Island accident.
Right.
That obviously had to affect it, but does it like wash out? Or does it spread? You know what I mean? Like, as it dissipates, does it?
Does it dissipate? That is an excellent question. And when we look at the various contaminants, what we see more often than not, if they're not neutralized in any way, that they accumulate more so than just dissipate. So there's an accumulation. That's why when you want to do something special in an area, you always do a soil sample. You have to go several feet down in order to test the layers of soil that's there. Or if you know that there was a place where, let's say, it was a dumping ground or a landfill, you're always doing a core sample of the site. Organics and things like that will build up, accumulate over time. 80% of radioactive material, or 80% of the exposures from natural sources, rock, soil, cosmic radiation, radon gas, 20% from man-made sources. The nuclide, by definition, is the atomic form of an element characterized by the number of protons, neutrons that's in the nucleus, and around that nucleus is the electrons. Positive protons in the center, negatively charged electrons, okay? Opposite attracts there. Radionuclide is an unstable form of the nuclide there. And so that's what we're dealing with because it's emitting those rays and so forth, trying to become stable. The Office of Air and Radiation is out there for more information on it. Now, we talked about the 4 that were regulated. We have the combined radium-226, 228. We have the adjusted growth alpha, the beta particles, and then uranium was that 4th one that was added in 2000. And as you can see, for the most part, naturally occurring. Here may occur due to contamination from facilities using or producing radioactive materials with the beta particles, but again with the uranium, naturally occurring. Health effects, all of them mention the increased cancer risk as well as kidney. So, Linda, you were absolutely right. Problems with the kidney with the uranium. Okay, we've gone through that there. Requirements of the 2000 radionuclides rule. Again, it's going to apply to your community water systems. Minimum of 15 service connection or 25 or more people, year-round basis, providing potable water for human consumption. Consideration for future proposal for your non-transient, non-community water systems. In other words, your non-transient, non-community water systems are not bound by the radionuclide rule. Yet. But you remember that question earlier?
Yep.
Yet. They are not bound by this rule as of yet. But it's probably coming. So the future proposal is that, again, that they be considered. And what we mean by that is you have 25 of the same people, and Kevin told us those were school, churches, nursing homes, factories. Okay, non-transient because you have 25 of the same people. And so if the proposal is for them in the near future, then what about the transient? Probably not far behind. Transient would be like your hotels, your motels, service stations. So that's coming. Uranium was added in 2000. Initially, they were kind of playing around with that maximum contaminant level. Initially, they were looking at 20, but they determined that 30 was probably okay. And so the MCL is 30 micrograms per liter. Again, the goal was still 0. But was it economical for everybody to achieve that? What were the health effects? These are sort of the things that they ask and they investigate in order to come up with a number that is valid. Another requirement of the 2000 rule was that they wanted to make sure that all water entering the distribution system is tested. So at that point of entry, you want to pull to make sure that you're within under the MCL. So some of the options, treatment options for radionuclides, we saw all of these and talked about them in the previous chapter, so we won't go into much details, but ion exchange, remember we talked about that one, where again, chloride is widely used when you're doing ion exchanges. Reverse osmosis, lime softening, green sand filtration, as well as coagulation filtration.
What's the lime salt?
Adding soda ash, caustic soda, raising the pH.
Oh, that's what that means.
Yeah. Reverse osmosis, out of all of these, is very effective in removing all 4. Some of the others not so effective. But RO will handle all 4 of them. And you have this chart in your book there, courtesy of EPA. And again, it gives you the treatment technology. IX is ion exchange. Okay, so they should have a lead in there as to what each of them are. Okay? And then which contaminant it works best with. That's what the checks are. So you can see for reverse osmosis, does good to remove all 4 of them. None of the others will remove all 4 as with the reverse osmosis.
What's the POU or
Good point of use.
well, at the source?
Yeah.
Then the other one is what it's the same?
Our point of use would be at the second. Right.
Oh, okay, that's it, the same. Yeah, then just the source.
Okay.
Okay.
Yeah, it should be. You should have
Oh, okay.
a legend there or something to tell
Yeah,
you
it
exactly what it is. Yeah. Are there any questions, comments, concerns, or issues? None? So, which one of the treatment options? Yeah, they're saying, yay, we're all done with that particular one. So which one of the treatment option is best to remove all of us? First osmosis. Let her answer. She's doing excellent. She's like, I'm listening. She's like, you all are making me sit through these classes.
She needs an honorary waterway system.
You need to call on her and make her.
Okay. All right, Laura, you got the next questions coming.
How you going through me for?
She's just like a sister. I didn't mean to get you in trouble.
Yeah, you did.
All right, module 9. We got 2 more modules. Huh?
I said, where's Ed? I'm telling you.
Module 9, filter backwash recycling route. Now, this was requested, but I was told in this area, you all deal mostly with groundwater. Do you have groundwater under the influence of surface water? Occasionally. Do you make your groundwater under the influence of surface water, direct influence of surface water? Do you make them do the treatment required for surface water? Yes?
We do have 2 groundwater systems that, I know one system that's pretty much a service for the plant filtration because of all the TSCs they have in the water. But we do have 3 systems that do have all filters and stuff.
Oh, that still have the filters, even groundwater. Do they disinfect with chlorine?
Yes, one
Plus
system.
filter?
Yes, one does, actually does chlorine because of their disinfection
Right.
byproducts.
Okay. All right, then this is a chlorine.
Is that one thing that you're talking about?
No, that's Bethany Beach. Bethany Beach pretty much has surface water 24 groundwater system. Yeah.
I thought they got rid of chlorines.
Yeah, they're the only ones that
They're
chlorine.
using aeration and,
Nope, they use aeration, so settling tank. Bethany Beach?
They use aeration for
Why
what?
did you Bethany Beach?
This is interesting now.
No, they still don't.
Uh-huh. Okay.
Just a,
What are they using the aeration for?
well, iron.
For the iron?
and
Okay.
they have
So
a big
we can-
settling tank or
Oxidize.
decanter, they use manganese, a bunch of oxide resin, they use filters, filtration, they do chloramine, they get that distribution system to do disinfection byproducts now.
So when we're talking about filters for the most part, why were filters introduced as a part of water treatment? Anybody know? I don't know. Ledge? Why were filters introduced as a part of water treatment?
You don't dig stuff out.
To do what?
To give you a more of a polished look.
More of a polished look? Remove contaminants. What contaminants in particular?
So,
Y'all are right,
Yeah.
Okay, turbidity particles, cool. And then the turbidity particles that harbor certain organisms that would hide in there, pathogen, cryptosporidium and giardia. Yeah, you got the bomb there, you got the bomb. Why? Because those organisms are chlorine resistant. Okay, so we can add chlorine all day long. These little boogers say, hey, you're still here, causing havoc. And so because of that, we have to find another alternative method of removing those organisms out of the water source. Filtration gave us that option to remove them. Okay. So, we filter. What's happening to our filter?
Selling off.
Yeah, it's falling up and all of that. So periodically we gotta do what?
Backwash.
Reverse that flow.
It's just like a swimming pool.
Just like in a swimming pool. Absolutely. So that's what this rule is about. How do we backwash? Why do we backwash? What are some of the concerns with backwash? Is there a possibility of cross-contamination when you are backwashing? Now we have the same issue that we just removed from the water, right? So you want to look at that, and not only look at that, we need to have rules and regs so we all get it right. So we're going to talk about the filter backwash recycling rule, and we'll look at the overview as well as the various methods for filter backwash recycling compliance. Right, the purpose was to ensure adequate level of public health protection by minimizing the risks associated with, and King Richard got the prize. Okay, he didn't, real King Richard, not the one that was found in the parking lot, the cryptosporidium. Okay. All right, Milwaukee, 1993, what happened? Over 400,000 people were affected. Why?
That's got in the beer.
Some got in the beer, what the water, huh? Bad filters, bad filters.
The backwash where the wastewater went down, the river, and came right into the river.
Actually, it was a filter problem that kind of got them in trouble there. I know they, and I saw, I don't know how many of you, this has been a while back though. There was a show that used to come on about monsters inside me. Did you all ever see that? And they actually did the study when they did a case dealing with the Milwaukee outbreak. And some of the things that they were looking at, possible cross-contamination, even with cattle being near their intake and things like that. And, you know, because of the Giardia and cryptosporidium, they went as far as even doing a study from the feces and saying, well, no, it was a different species. So that was not the culprit. They had a compromised filter. Over a span of 2 weeks, this water went through 403,000 people were infected. Over 100 died because of it, or deaths. And again, it ran the gamut from cramps, fever, diarrhea, dehydration. The 104 that died were the elderly, compromised immune systems, or AIDS patients. So this was something that was a big deal. Cryptosporidium, that little thing there, that 006, chlorine resistant. Huh?
So it looks like Manila's tennis ball. Line layer on.
After you had it, yeah. Highly resistant to chlorine. So it's not easily deactivated with common disinfection technique, and because of that, filtration, alternate methods of taking that out became evident. So the primary objective of the filter backwash recycling rule was to ensure an adequate level of public health by minimizing the risk associated with cryptosporidium in your bag flows there, or recycle flows. Under the interim enhanced surface water treatment rule and long-term one surface water treatment rule, this was also an issue that they took into consideration, and they said that under these rules you must be able to remove a two-log removal of cryptosporidium for your surface water or your GUI systems, which were groundwater under the influence or direct influence of your surface water. Now, although there are more than 3 recycle streams, there are 3 regulated recycle streams. There are 3 regulated recycle streams. There are 3 regulated recycle streams. You got that?
We got that, yeah.
Okay, cool.
How many are there?
There's 3.
There's 3.
So I put down 1,
I need to.
But now you got it.
because I didn't know.
Yeah. Yeah, and they took a pre-test. So.
Right.
The spent filter backwash water, the thickener supernate, and liquids from the dewatering process are the ones that are regulated. Okay. Your recycle streams may affect the treatment process due to hydraulic surges or high concentration of contaminants that's in the recycling stream. The unregulated ones, but they are still considered recycled streams, would be filtered to waste or membrane concentrate, ion exchange regenerant, sludge, or your diatomaceous earth slurry. So, criteria of this particular rule. This is applicable to all of the systems that are in the subpart H system. Well, what constitute the ones that are in the subpart H? You're talking in your surface water, because filtration is a requirement, or your groundwater under the direct influence of surface water. Why? Because with those systems, we see the same sort of organisms as in the surface water. Okay. And so how do I determine if my groundwater is under the influence of surface water? What do I need to do?
Well, your primacy agency makes the final determination.
Okay, and as the primacy agency will probably say, you're gonna get out there and do some surveys and studies, right? If there's a possibility that every time it rains, there's a fluctuation in your water quality, and it correlates to all of those temperature differences and rainfalls and things like that, what's going on? Possibility. If all of a sudden I start seeing microorganisms and insects, parts, and things like that in my groundwater, which should have been filtered out, it's a possibility something's getting in it, right? We have to do the surveys in order to determine that. All right. The other criteria was anything that treats the water by conventional filtration or direct filtration. The difference between those two, conventional, we have sedimentation tanks there. So we have the process of adding chemicals to the water for coagulation to occur, and a sedimentation basin where your heavy solid or block can settle out, and from there it goes to filtration. That's the conventional method. It's what to use. Direct filtration, adding coagulant in, going through a rapid mix, no sedimentation, but directly to filtration. So you have a system that employs either of those, then you're subject to the filter backwash recycling rule. There are three components of this rule: reporting, recycle return location, and record keeping. You gotta keep up with. As far as reporting, the information that EPA says must be readily available, plant schematics showing the origin of all flows recycled, recycle flow previous year highest observed, as well as the design flow for your treatment facility.
But this isn't for all treatments, right?
No, surface water, groundwater under the influence that are employing the same treatment techniques as your surface water, or if you have conventional or direct filtration. Most groundwater systems, for the most part, what do they do?
I didn't want to say it.
Just some form of disinfection. That's really the only requirement, unless you have a different water quality. And Bill is like, no, you all do a little more.
You don't even require disinfectant.
Oh, you're not even required to disinfect here.
Unless you've had a history of
Therefore, a
travel.
little of that love taken back of the public water systems.
Right, yeah.
Communities even, we don't require them to disinfect.
Unless there's a history of back teeth problem.
Or if we get a positive, then they're in trouble.
Okay,
I mean, it's really
That's
like
different.
that.
Yes.
that's different.
Yeah. Multiple whole fund violations and we'll order them continuously for
Okay, and so most of your systems, there's no disinfection of some.
Majority are, I would say.
Yeah, a lot of them now, because the big utilities, as a matter of their policies, they will disinfect the
Yeah.
systems, and they're taking over more and more. But the small mobile home parks, for the most part, are untreated.
Completely.
Wow.
I think all of the large systems are all
Large ones, pretty much all.
the surface, of course.
Okay, yeah, surface for sure. The ground one, it's interesting. Do the utilities disinfect because of an indemnification clause with the companies that are operating the systems?
They
a large utility here in Delaware was purchased by, their parent company's in New Jersey, and New Jersey has a rule that all communities have to chlorinate, so then they just did what their parent company was doing.
Gotcha. See, I learned something new every day. Well, it's not a requirement yet. All right. We also need to include in this report the state-approved operating capacity for the plant. Now, as far as giving them all the chemical dosing information as a part of the final report, not a requirement. But of course, you're keeping up with that. Anything that you do at that facility, you want to make sure that you're documenting. But it's just not a required component of the report. Yes, Linda? Sure? Good, okay. Recycle return location, your recycle streams should be returned through all the processes of the system, existing filtration system that's in place. Also introduce at a point that incorporate all the treatment process. Or if you don't go that option, you need to start looking at capital improvements to remove the recycled location or request approval for an alternative recycle location. Record keeping, if it's not, it wasn't done, is always my motto. So you want to make sure that you're keeping good records. You want to list the recycle streams, the frequency of their return, average maximum backwash rates, the process in minutes. And again, this is all based on what does your manufacturer recommend? How many hours of operation before a backwash? Is this something that the operator can determine how long they need, when they need to backwash, and how long they're going to backwash?
Time and turbidity.
Absolutely, turbidity plays a major part. And then I have this new thing that's called a gauge, head of loss gauge. Does that play a part in it?
Yep.
Yeah, 6 to 10 feet. So you have things in place that helps you to know when it's time to backwash. Typical filter run length is again determined by head loss, turbidity, time, etc. there. All right. Record keeping, type of treatment provided for the recycled stream before it re-enters the conventional or direct filtration process, as well as the physical dimensions of the equalization of treatment units, hydraulic loading rates, chemicals, anything like that that may be applicable. Okay, you have a checklist of all of that we just went over on 9-8. Your checklist to make sure you have it in place. All right, regulated streams. How many regulated streams did we say? Three. Super. With your spent filter backwash water, again, you may have concentrates of microbial particles such as Giardia or Cryptosporidium. That's why we're concerned. Thickener supernate. What's a thickener?
It'd be like a, yeah,
I heard clarify.
like alum or something like that. Just take the particles and stick them down to the bottom and skim it off.
Okay.
So do a surface water plants.
Polymer.
They use alum and flock.
Some people do add polymer to help the solids as far as thickening up. We're trying to concentrate the solids, so we're putting them in an area or a basin, which there is separation by gravity between your solids and your liquid. And so the supernate is usually what is usually returned. And so in there, again, you may have elevated microbial contaminants as well as some other things there. Supernate would be that, I won't say clarified, but it should be a lot clearer than the solids that are concentrated at the bottom. And then we have liquids from dewatering processes. Again, at a lot of your facilities, after you have the accumulation of solids, you remove the water via belt presses, where you have a series of belts that you're literally pressing the water out. Instead of huge high spin in order to remove the water. Drying beds can be assisted by vacuum, or it just could be a sand deal there. What are we doing with the water that's being squeezed out? Or the water?
Goes back to the plant.
Yeah, okay. So again, concentrated amounts of cryptosporidium, aluminum, if your plant is using alum for coagulation, as well as some other things that may be of concern with this recycled water. That's why it's important to have this rule in place. And they talk about your unregulated streams, but right now, for the most part, these are not streams that are regulated. Most of the water in most of these, like the filtered to waste, it can be recycled or disposed of. With the membrane concentrate, I think Bridget, we talked about that earlier. If you're going to dispose of it, I know in some areas you have to have every place, if you're going to put it back into the waters of the nation, you gotta have a permit to do that. You want to make sure that you are paying attention to the industrial use or sewer use ordinance if you're going to use a sanitary sewer. Of course, land application may be an option, but even with land application, you have to run the tests. You can't just go out there and apply it to the land. It has to meet certain criteria before you can apply that to the land. So most of those, unregulated streams, you can do what you need to do. Okay. Yes.
We only have one water system in Delaware that recycles, one surface water system that recycles the backwash water.
Really? Just one.
Yeah, but that one is 1/3 of our surface water system.
I'm a porter. They keep on
There's only three.
The solids they make the cakes when they sell the fertilizer, but keep on recycling the water.
It was united with the
It's
Gulf
United.
Coast and all.
Yeah, it's United.
Wilmington shows what the membranes now.
Well, that's the branding line.
Yeah, I don't know what they're gonna be doing with it, with the membranes. But we do have a lot of groundwater systems that are starting to recycle their backwash water. They converted gravity ground level storage tanks into backwash tanks and decant the water off and pull the sludge out of the bottom. Iron removal.
Of the ground storage tanks. That's interesting.
Or they got the ponds they put out there. When it gets so full, they have a truck come and they scoop it off in the hallway of the iron. Yes.
So do they use alternative ground storage or?
Yes. like
Okay.
They have another, like a elevated storage tank at another location. They don't need that gravity ground level tank anymore, so they
Right.
convert it to a backwash water tank.
Okay. And so a lot of your groundwater systems have filters, but not disinfectant residual.
Most of those add chlorine to help precipitate iron, so
Right.
they do have.
What do you do with, as far as your distribution system goes? No residual is required in the distribution system?
Required. Now,
Yeah.
if we do require it, we require more than other states. We require a 0.3 at the end of the line, if we require it.
If its system disinfects or uses chlorine, they have to maintain 0.3 at the farthest end of the distribution system. If they chlorinate, we just don't mandate chlorination.
But we don't request any records of them proving anything. We probably should do that.
A waterworks report, Danny, and then where they collected
You're not
some
gonna
collected
find one in there that says anyone's in the system that got a sample.
for Hogan.
Well, not any of my systems.
You'll special byproducts, you'll
Oh.
get a chlorine residual too, you'll know.
So you have no problems with bacteria from month to month to month to month? For
Well,
the ones that are not chlorinating?
Occasionally.
summers on
But not a lot.
No, the ones that we do, we make them chlorinate.
So most of your lines are not an issue. Do you all frequently clean out your water lines?
Flushing
Don't
program.
build up? Well, flushing programs, again, do you do that monthly, dead
smaller
ends?
rural parks don't have that ability. They don't have 4-inch
I think Dover does it twice a year.
Yeah.
Because they've been there forever, before there was regulation.
We
Put a
recommend
blow-
flush
blow
filter.
off, okay, yeah, you can put a blow on that.
Yeah.
Yeah, but it's not the same as having a regular system where things can be valved. They have no valves anywhere. And when they blow it off, they disconnect the trailer and that's it. You have a 3/4 inch line. It's not very effective.
That's it.
That's mobile home parks. Some mobile, older mobile.
All right, treatment options for your recycled streams. Could be just sedimentation in a lagoon. It's very economical. All you need is land space in order to utilize this method. There's no separate tank to equalize the incoming flow. The design should also incorporate frequent sludge removal, which I heard Tommy said, from time to time, that's a necessity, because if not, that will build up, and if you have any type of flow in, there's a possibility of flow backwards now, cross-contamination. Consider the contamination of the recycle flow by sources outside the lagoon, such as your chemical delivery trucks. You want to make sure that they have proper cross-connection control in place, and your lagoon must be lined with impervious layer to prevent groundwater contamination. Okay, chemical additions, sedimentation enhanced by the addition of chemicals. In order to be efficient and effective, you need to make sure that you're running jar tests for proper application of the chemicals in which you're wanting to use for wet dosing. Tube and plate setters, that's another alternative or treatment option. It allows greater loading rates. Your tubes and plates, however, can become very easily clogged. Uneven flows can also create issues there. The type of chemical mixing will depend on your plant, how it's laid out. There's a grade line, all of that, and the design flow rate. Advantages and disadvantages would be properly designed and operated, remove significant amounts of turbidity particles when you do have that type of sedimentation, be it any of those. Disinfection byproduct of precursors may also be removed when the overflow rates are low enough. When we talk about disinfection byproducts, what are we talking about? Where do they come from? And in your case, you probably don't have them because you don't chlorinate.
Oh, we have this one, right?
You have that. So where do you get the disinfection byproducts from? The ones that do chlorinate?
Yes.
Okay, cool. So these byproducts are formed when we have excessive amount of chlorine in the naturally organic matter, such as leaves and other things like that. Too much chlorine, it's looking for something to bind with. It binds with this. Now it creates trihalomethanes and halioacidic acids, which are cancer causing. And now those two are regulated. So, improper design can lead to poor solids removal. Adequate equalization and storage may be necessary. And again, if you don't want to compromise your treatment process, you got to make sure that you have sludge removal. What will happen over time, there's no agitation. Septicity can occur just like a wastewater treatment facility. Other option, treatment option, micro sand assisted sedimentation. It's been around for a while. It too, like with the chemical addition, rely heavily on the addition of a coagulant to improve the process of flocculation and settling, clarifying the top portion. Microsand is separated, recycled in the system numerous times. You have a quick process startup time, but short processing may occur, which now may not be as effective as desired. It requires a small footprint. And we have dissolved air flotation, another option there that can be used, commonly used there. And it's used widely on the wastewater side also, where you're injecting air in order to help move the solids up. Very effective in removing low density particles. We have granular bed filtration. Higher cost, complex process, greater volume of waste there. treatment by chemical addition with flocculation prior to the filter should be practiced when you are considering this. And then membrane filtration. With membrane filtration, you can have a micro filtration particle, ultra filtration, and also, I don't know if you would want to put, because that's a big expense, but RO is also considered a membrane techniques there. So you do get high levels of particle removals. Complex equipment, again, your membranes are subjected to fouling. Disinfection. Now this can be a barrier to recycling of pathogens there. Disinfection or chlorination is recommended for your recycled streams. But keep in mind, you can also be creating some of the disinfectant byproducts at the same time. Consider the level of inactivation that's necessary. Solid removal. You want to make sure you plate that out in your mind. And the potential impact of the finished water quality. Again, those disinfection byproducts, that's a real thing to take into consideration. And then what pathogens do you have in a recycled stream? If I have the Giardia and Cryptosporidium that somehow is there, chlorination is not going to do much good. All right, we'd like out of time and time for a break. Are there any questions, comments, concerns, or issues? What I need you all to do at this point, prior to break, if you will, is just initial for the evening, and then we'll take a 15-minute break. And after that 15-minute break, we have one more module, and then we'll be ready to go.